Good evening, students. Myself, Nikita Patil, Assistant Professor, Changu Kana Thakur Arts, Commerce and Science College, New Panvel, Empowered Autonomous. Today we are discussing about the topic that is tree in the data structure. So let us see first point that what exactly our tree is. The tree is a hierarchical data structures used in organize and represent data in a parent-child relationship that we can represent the hierarchy over there. It consists of nodes where the two topmost node is always called as the root and every other nodes we have one or more child nodes. So the definitions of the tree is defined as recursively as follows, that is a set of zero items is a tree called as the empty tree or the null tree. If T1, T2 up to Tn are the trees of n is always greater than 0 and R is an item called a node, then set T containing the R and the trees T1, T2 up to Tn is a tree. Now see, this is the actual representations of the tree. Here the gray box represent the internal nodes and the green box represent the leaf nodes. So depends upon that diagram we are discussing about the terminologies of the trees. Now let us see the terminologies of the tree. So first terminology is the parent node. So in the diagram they are representing the 15 number, that is the 15 node is a root node and the left child node is your 35 and the right child node is your 40. So the parent node is a node that is an intermediate procedure of another nodes, that for example 35 is the parent of 3 and the 6. Now because 3 and the 6 which is derived from the node that is 35. Now next one is your child node. So let us consider that node is an intermediate successor of the another node. So 3 and 6 are the child nodes of the 35. Same as the in the above diagram, there will be the 40 is a parent node and there 5 and 7 is the child node. Now move on to the next terminology, that is leaf node, that we consider as the external node. So node that do not have any children, for example 1, 10, 12, 5, 7 and 7 are the leaf nodes, means they has to terminate their tree, that we consider as the leaf node. Now next one is your ancestors. Any nodes on the path from root to a given node excluding the node itself. So for example 15 and 35 are the ancestors of the 10 node. Now next is your descendant. A node x is a descendant of the another node y if y is an ancestor of x. For example 1, 10 and the 6 are the descendant of the 35 in the given diagram. Now the next terminology is sibling. Nodes that shares the same parent. For example 1 and 10 are the siblings and 5 and 7 are the siblings, because it consists as the same nodes, it is derived from the same node. Now the level of the node, the number of the edges in the path from the root of that node, the root node is the at level 0. So 15 is our root node which is present in the level 0. Now 35, 9 and 40 is our next node which is in the level number 1 and so on. Now next one is your internal node. A node with at least one child we are considered as the internal node. Now in the given diagram the 35 is your internal node. Next one is your neighbor of the node, the parent or the children of a node we are considered as the neighbor of the node. Now consider the next terminology, that is subtree. A node and all it descend now from a subtree. Degree of the tree, the degree of the tree is maximum degree of the node in the tree. Now in the given diagram the 15, that root our 15 is our root node, but our 15 node has the three child nodes, that is 35, 9 and 40. Same as the our node is 5 that has the three child, so our degree of the tree will be 3 because has the maximum child nodes. Now the next terminology is path. A sequence of consecutive edges is called as the path. We can consider that is the left subskew and the right subskew, that is the path. So it will be derived from 15, 35, 3 and 1. This is your left subtree and 1547, this is your right subtree. Now height, the height number of the node that is possible in a way starting from the first node of a leaf node is called as the height of the tree. So always we are start with the root node, and we are starting with the left side of the tree. So these are the some terminologies of the trees. Now instead of this we are consider as that is the terminations node, then the uh, leaf. Okay. Now we are start with the next topic, that is the types of the tree. So first we are see the type of the tree, that is the first tree, that is the binary tree. Okay, so binary, which is basically considered as the two values, that is 0 and 1. So binary tree is a finite sets of element which is empty, or it is partitions into three disjoint sets. So the first subset contains the element called the root of the tree, and the other two subsets are called themselves as the binary tree, called the left and the right subtree of the original tree. So basically the binary tree, which is considered as the tree has at least one or the two child, not more than the two child, we are considered as the binary tree. The next topic is that is complete binary tree. So the binary tree we are discussing, that is at least one or two chairs. Now how we consider as the complete binary tree? A binary tree is a complete binary tree if all the levels are completely filled except possibly the last level, and the last level is filled from the left side only. A complete binary tree just like a full binary tree, but with two major differences. First one is every level except the last level must be completely filled. All the leaf element must lean towards the left. Means in your complete binary tree we can consider that all the nodes which is filled up with the left side also and right side also, but the another way we can consider that one term at the level end, at the termination end, your node which is considered as at least the left side node will be the present, that right side node will be absent. So that tree also we will consider as the complete binary tree. So see in the given diagram that A is your root node, B and C are the child of your root node. Again in the B has the two childs, that is D and E, but the node that is C has the only left side node, which the right side node is the absent. So we are taking that every layer except that last level must be the completely filled, but our condition is that except possibility the last level and the last level is filled up from the left side. So in the above diagram that the last level which is completely filled up with the left side, so we are consider as this tree is called as the complete binary tree. Next one is your perfect binary tree. So a binary tree which is a perfect binary tree in which all the internal nodes have two children and all leaf nodes are at the same level. So perfect binary tree is a type of binary tree in which every internal node has exactly two child nodes and all the leaf nodes are at the same level. In a perfect binary tree, the number of leaf node is the number of internal node plus 1. So consider in the given diagram, the root node has their two childs, that is 2 and 3. That is 1 is our root node, that 2 and 3 our child node. But 2 has again 4 and 5 are the root node. 4 and 5 has their child nodes, and the node 3 has the child 6 and 7. So every field will be filled up with the left node also and right node also. So these tree structure we are consider as the perfect binary tree. So these are the types of the binary tree, that is binary tree. These are the types of the tree, that is binary tree, complete binary tree and the perfect binary tree. Thank you.